Hi, I'm Bob Calco from Apex Data Solutions, and this lightning talk is called Introducing Visual Scheme, Modernizing Office Solutions on the CLR. The Reader's Digest condensed version of my bio there is that I'm an experienced enterprise architect with a knack for integrating things and an engineer of distributed solutions. As you can see, I'm a bit of a polyglot, and I have been traveling on my road to Lisp for the last 6 or 7 years. Hey, we're going to take about 20 minutes in this pre-recorded presentation to get a quick overview of our use of Scheme in a real-world commercial product that's aimed at modernizing Office solutions by putting them on a linked data microservices architecture. The overview will be super high level. This is not a product pitch, but rather talk about why we chose Scheme for this role in Office. Since the scheme that we're using runs on .NET, it's called Iron Scheme if you want to look it up. We'll briefly discuss how the tag team of Scheme on the one hand and the common language runtime or .NET on the other can add real value in this effort. And then finally, we'll take whatever 5 or 10 minutes are left for Q&A. So without further ado, let's run through a quick tour of what we built. Add-ins in Office can define their own tabs, and we've added one for Accelerate that makes it easy to access the 4 functions that we created to extend writing formulas in Excel. The lambda function, which allows you to execute an anonymous lambda in a specific cell. The define function, which creates a named lambda that you can call in the cell where it is defined, or simply refer to it from another lambda or as a named region in Excel. There's the apply function. This allows you to perform computations over 2D regions in the spreadsheet by row or by column. We have special support for that. There's an eval function, finally, that can call a named lambda or execute an anonymous one, very similar to how you could do it in the lambda function. All of this offers functionality similar to Microsoft's new LET and LAMBDA functions added to their expression language. We think that our approach offers some interesting capabilities that are worth using, that make it worth using scheme lambdas alongside, or in any case, in many cases, instead of Microsoft's new additions to Excel's popular formula expression language. This tab also lets you toggle the built-in REPL or open a command line REPL or a terminal prompt, and some very basic logging features and access to our online help is also just a click away. The Lambda editor there in the middle appears when you focus on a cell that uses one of our 4 Lambda-related functions. Provides an editor with full syntax highlighting and simple pretty printing. The pretty printing is necessary because the code needs to get crunched into a one-liner and fit within Excel's string limitations in order to be called. This, by the way, is a reason why a language like Python would be harder to do this with, because it actually depends on white space. That's not going to work in Excel. So here, Lisp is a great answer. Okay, so we also have a place to add arguments that you can pass to the Lambda, and a preview of the function minified is also provided. It's the minified version that your hard limits are up against anyway. Those hard limits in Excel are roughly roughly the main reason, but not the only reason, why we also allow libraries of functions to be accessed from within Excel that reside on the user hard drive in an extensible search path. So literally almost any scheme code out there can be accessed from inside a Lambda call. You can see here in the REPL that we're interacting with the well-known mini canron library, for example. It works beautifully inside here. This is one huge distinction between the lambdas that users create in Scheme versus the lambdas that users can create in Excel's new LET and LAMBDA functions. The ability to reach outside Excel into Scheme libraries, including SRFIs that are implemented in Iron Scheme. And because it runs on .NET, it also allows for full reach into the .NET libraries and frameworks that are available out there, which are legion. Okay, so finally, the REPL off to the side allows you to experiment with functions before you commit them to code, whether by adding them from the hard drive or in the spreadsheet. That's what we've done here. We copied the Lambda portion of the definition from the REPL to the Lambda editor. We gave it a name, and now it's available to other Lambda calls, and it's persistent if you save and reopen the workbook. Calling named lambdas is easy with the eval function, as you can see here. We're simply calling the appendos lambda that we named in the previous step. Obviously, I could have done more to format the result in the spreadsheet, but this gives you an idea of the interplay we were looking for. And Scheme made it really not just easy, but fun. This was actually a really fun project getting this to work. And finally, we offer command line REPL and external script execution. So you're not limited to running inside the Office applications. Any code that you write on the hard drive can be used both inside and outside of Excel, for example, which is very different from lambdas implemented in Excel's built-in formula language. These can only exist in the world created by Excel at runtime. Although in the professional edition, we plan to supply a built-in code editor. For now, or as long as you wish, you can always use your own favorite external editor when working on code outside of the Office suite. I'm a fan of Emacs, but your mileage may vary, and there's lots of choices. So that's it for the quick tour. As you can see, we've brought proper REPL-driven development to Excel, of all places, both inside of it and at the command line. Automation scripts are easy to write and run against a huge number of well-known libraries that we provide out of the box for logging, CSV parsing, database connections, both SQL and NoSQL through LiteDB, for RDF and linked data and interacting with the Office APIs and document interfaces. We have a lot under the hood that's worth exploring, suitable for serious development of solutions. And for more details on that aspect, you can refer to the article linked here at Code Magazine. And obviously, if you're interested, you could check out our free trial. Yeah, that's it for the pitch. So why did we do this? Why did we choose Scheme to integrate into Excel? It's a great choice, but it's also a good question because it's not an obvious one to many people. I imagine as Scheme developers, I don't have much of a sale here that I have to do, but it does require explanation, and so here we are. It boils down for us to the raw power of syntax extensions. So much of .NET can be intimidating to VBA programmers or power users, and we needed a scripting language based on a tiny syntax, simple to learn, but also powerful enough to shape the integration with .NET in ways that make code more functional, declarative, and value added, with, again, minimal syntax. And this is really where Scheme shined. In this screenshot over here, you can see that we use macros quite a bit, even in our unit tests. We got SQLite custom functions and unit test execution that reads like plain English. None of this would be done, least of all easily, without the syntax extension facility of Scheme, which is just incredibly powerful. And I really became a true believer when I was working on this. Okay, so let's take a closer look at the definitions of the SQLite custom functions from a few slides back. You'll note that the syntax here that we were aiming for feels a bit like Haskell function definitions. In this sense, the code is self-documenting, but it's also how under the hood the function is registered with the correct generic parameters in Microsoft SQLite's delegate-based API for creating such functions. If you look carefully, you'll see that the ultimate answer function takes 0 parameters and returns an integer, int32. The times2 function takes 1 int32 parameter and returns an int32. The add3 function takes 3 int32 parameters and returns an int32. All 3 of them are marked pure, which tells the SQLite engine that the functions are referentially transparent, which in turn allows it to perform some optimizations, making them execute faster. All 3 of these are being created on the previously defined MemoryDB connection to SQLite that it was in the script earlier. So from my point of view, it's really hard to imagine doing anything this creative, expressive, and more to the point, simplifying in anything but a proper Lisp-like scheme. Um, Even for a C# developer, writing such functions is actually quite a lot of ceremony and boilerplate. And we've got it down to practically one-liners, depending on, your Lambda. Um, I have to say this is, one of my favorite aspects of it, for sure. In part because I can not just create a Lambda there in line, but I can also call one that's already been created or just refer to it by name. So the same Lambdas that could be running in the spreadsheet could be being called through the SQLite extension. I mean, that's, talk about code reuse. That's probably my favorite feature right now. Okay, so this is a peek at the syntax extension we wrote to add custom functions to SQLite. It leverages Iron Scheme's support for calling into the CLR with idiomatic scheme code. So there's really no funky syntax here. This is idiomatic scheme code that talks right directly to the .NET runtime abstractions that are available and allows you to put nice idiomatic scheme wrappers around them. The pattern matching feature of syntax extensions was especially helpful in getting precisely the user experience I wanted, which you saw in the last slide, right? That was the self-documenting and also powerful implementation of delegates behind the scenes. It was especially helpful to get that experience while at the same time not becoming too hard to read as a macro. It often surprised me working on syntax extensions how simple they ended up being after just a few iterations. I go into them thinking, man, this is going to be ugly, but usually the result's quite elegant. The key here, I suppose, is having a clear idea of how the user of your extension will make use of it. And the most pleasant surprise is how much control you have over that. I know most people value the hygienic nature of Scheme's approach to macros, but that's probably the part I care about least. What I really love is the ability to craft expressive DSLs that look and feel and behave intuitively. Although the pattern matching syntax is knocked for not being kind of purist in the list sense, I've only ever had good experiences coding pattern matching expressions, whether in Scheme syntax, extensions, or in other languages like F# on .NET, where they're used pervasively and for good reason. Okay, let's look at the second example here. This is the define enumerable syntax extension that we implemented. This creates a bridge between .NET iterators as expressed in the IEnumerable and IEnumerator interfaces and the iterators defined in Iron Scheme's LINQ implementation. Now, some of you might not know what LINQ is. It stands for Language Integrated Query, and it was added to C# and VB.NET some time ago as a kind of built-in DSL for writing queries against generic collections. It's almost trivial as long as you're working with collections that implement IEnumerable and IEnumerator. It's also worth pointing out that LINQ in Scheme has nothing to do with LINQ in C#, where it was popularized, except for being based on the same specification and implemented in a very economical 900 lines or so of pure Scheme code. I mean, basically a weekend project. The end result of which is a SQLite DSL for frisking generic collections. You can't do that, certainly not so easily in a non-Lisp language, that's for sure. In case you're wondering what they look like here, this is just to give you a quick visual of what LINQ expressions, how they're used. Hopefully the font's big enough so you can see it. As I hope you can see, they basically look like SQL queries. And they're very similar to Common Lisp's controversial loop macro, except they work with anything that's iterable. That is to say, any generic collection that implements the iterator functions required for the behavior to work. Under the hood, the concept of iterator is implemented as a normal Scheme record, and instances specific to built-in Scheme collection types are provided for the usual suspects: lists, vectors, hash tables, etc. Indeed, that's most of the 900 lines of code in the Iron Scheme LINQ implementation, to be honest. Any Scheme collection type you create in Scheme the usual Scheme way will likely require an implementation of iterator suitable for navigating its data, but as soon as you've implemented that, you can use it with the link extension. And with regard to .NET, obviously we were able to focus on the widely used IEnumerable and IEnumerator interfaces and create a single bridge for all .NET collections implementing them, which was very powerful. So here's what using the extension looks like. If your enumerable also implements an IEnumerator, it's basically a one-liner, as in the case of the Sylvan CSV data reader. That's the first code snippet there. If you have a more complicated interaction with those collections like we do in our .NET RDF wrappers, then it's maybe about 10 lines of code, depending on how crazy you go with error checking and providing default behavior. This was tricky because the interfaces on the .NET side are not well behaved. Indeed, there are a few gotchas in .NET and Iron Scheme to be aware of, so I'll cover those real quick in the next slide. So here are some of the gotchas I discovered along the way that are worth noting. In .NET, the IEnumerator interface, as I mentioned, seems to have been treated by most implementers as a mere suggestion rather than a contract. Particularly unreliable is the reset method, which may or may not apply to a given collection and can variously A, work, B, do nothing, C, throw an error. So I was able to account for that by always making reset create a fresh reference to the result of the enumerable's get enumerator. Also, in some strange cases, a specific typecast to the type of the implementation was necessary. Not always, but sometimes. If you don't know what that means, I can elaborate in Q&A, but the gist of it is that the IEnumerator interface in .NET is surprisingly ill-behaved. But we got it working, and the resulting macro is elegant and flexible to deal with these two main causes of pain. Another important limitation on .NET, and this is true on Kawa on the JVM as well, is the fact that the runtime doesn't give developers low-level constructs required to fully implement continuations in the true scheme sense. While there's support for call CC and friends, if you try to call a continuation outside the lexical scope where it was defined, you'll get a nice little error message from Iron Scheme telling you not to do that anymore. Finally, .NET Core removed the reflection emit alternative for saving the binary to disk. So it's not possible, except on the Windows-based .NET Framework flavor of the runtime, to compile a binary to disk at this time. Fortunately, Iron Scheme is very, very well designed as a fast scripting engine, and while this feature is missed with libraries that make heavy use of macros, for example, it's seldom a practical limitation on any other platform. Code once compiled runs in memory just as fast as code compiled in C# or VBNet in most cases. In other words, you won't notice this in Accelerate because the .NET framework is what's used to integrate into Office, so you can compile binaries in that environment. But when you go portable to say Linux or Mac, you won't be able to do that. All right, so one Iron Scheme gotcha at this time. You can't create classes or subclasses or implement interfaces. This is a known limitation that can probably be overcome with some effort, and Scheme folks are encouraged to work on Iron Scheme to add this feature. It's open source. It's maintained by someone named Llewellyn Pritchard, who's just a joy to work with. So if this is something you think you want to add or contribute, then hop right in. All right, almost there. Okay, so the bottom line is syntax extensions are such a critical core component of our use of Scheme because they make it easy to present our wide target audience with the simplest possible user experience. .NET is big and messy, but with some thoughtful extensions such as these that we've built, it can greatly simplify adoption by taming these scary bits for everyday users. It's hard to think of a bigger lever than Excel for moving the world to consider Scheme an industrial strength programming language in its own right, in any case. As I wind down the pre-recorded portion of this presentation, let me just briefly comment on what we mean by legacy app modernization. It may seem paradoxical to use a language as old as Scheme, not to mention Lisp, for modernizing applications, but there's a serious play here, and I hope people who love Scheme can join in it. We're basically trying to rethink what the industry means by legacy app modernization. Starting with Office solutions, which are typical of the legacy data silos you find all across the enterprise and small businesses and even on just about everybody's personal computers. We're focused on a notion of modern that anticipates a future state of IT readiness for real data interoperability. That's a whole separate speech. But that world doesn't exist yet, and we wouldn't be ready for it if it did. And so Accelerate is really our first tool to create that readiness state by turning dead document artifacts into living, breathing microservices. It's a great niche for Scheme, but really Scheme's a great fit for Office, turning its traditional weaknesses into its greatest strength and complementing more traditional developer tools like VBA and Excel's formula expression language. Anyway, with a forward-looking vision of a world in which true data interoperability is hopefully someday common, Scheme, particularly running on .NET from inside Office 365, can lead the way into that possible future. It's ambitious, that's true, but we're schemers after all. That's it for now. Obviously, that was high level, but we'd love to dig deeper into these topics if you're interested to hear more. If for whatever reason we run out of time, feel free to send more questions to info@apexdatasolutions.com. And of course, you can always visit our website, apexdatasolutions.com, for more information as well.